So recap of functions complete. This was all stuff we did last week. If you weren't here, now you basically were here. So welcome to last week, Bobby. Moving forward with this, we're gonna see what can we do with these functions? What can we do with relations that do not have repeated x values? That's what the function is, okay? So what I'll do now is pause for a second, make sure all y'all got the pro tips written down on your pages here. And once you're ready, go ahead and roll it over. The next page, next page over is going to describe increasing versus decreasing functions. That's page, I think, 36, Fernando?
Yeah.
Perfect. I'll do it. You won't do it. Okay, Swift. Thanks for staying on pace, fellas. I will remove this from the board and move cruise on. All right, so first, very simply, there's three types of things that can happen with a function. It's going to be increasing, it's going to be decreasing, or it's going to be remaining constant, staying the same. Increasing line, as long as it's got a positive slope from the left side to the right side, if it's gaining in altitude, it's going to have an increase in the function. So notice the far left version, our red graph is growing up. Doesn't have to be a straight line, by the way. As long as it's increasing, right? It ends higher on the right than it is on the left. That's the idea of an increasing function. So as long as it's cruising upward, that works. Decreasing functions are the opposite. They're going to be dropping down from left to right. The right edge is lower than the left. And lastly, we're going to have our pleasant constant lines. They're pure flat. I tried to draw it. Okay, it's not too bad. Without a ruler, it's hard to draw a straight line, but if the left and the right edge are the same, there is no change to this function over time. It's constant, and that's what we call it, okay? So these are the three things we're going to look for. How to identify it. Some functions, they change. Sometimes a function goes up, down, stays the same, goes up, drops. And so you might say, well, how do I know that that function is increasing or decreasing? It's doing all the things. So what we can see actually is that there are intervals where a change or certain trends are in existence here. My function, if I start the left edge here, it's increasing until I hit the first green line. Then I have a change of pace. Now I'm going to be decreasing from this section. Second green line, I change it up and I'm going into an increase of pace. At this next junction, I switch to flat, constant now. Then we increase and finally decrease. So if I ask you if a function's increasing or decreasing, I'm probably going to be talking about within a certain interval. If it's a function that's going up or down. It might not always be something so simple as these examples where it only demonstrates an increase. It only demonstrates a constant. But these are the three things that can happen as we track this function, all right? Below this, let's use some real world stuff, okay? Because this is where I'm going to need some of your help. Because I know what I see, but maybe what you see is going to be way more important. So I got homie blue in A. I have my center dude in a gold, and then I got my red dude. Now they're all actually pretty happy looking people. They all got a smile. So it doesn't matter for them if their function is increasing or decreasing or staying the same. But let's start with B actually, because B, what does he look like? My best impression here. It's been a while since I've had yoga class, but what do we notice about this man, or this woman, or this circular entity.
He's constant.
Constant, right? Well, that's the word we're supposed to describe. Did you say something else?
I said calm.
Calm. Okay, he's calm. Yeah, he is calm. He's calm because things are not changing. It is constant. I don't want to disinclude that word. It's just I wanted to maybe have a nice spread of words to describe this. Here's a word that I like to describe. It's flat. Or there is no change. All right, so a nice flat slope demonstrates a constant rate. We're not changing. Okay, so then let's cruise to the left. Words to describe, what is this guy doing? Which direction he's pointing? Look at his hand. His hand is pointing in this angle. Hand points up. Is that an alarm?
So
Doesn't sound like us at all.
is there a car alarm over there?
Oh, there we go. Speak of it and it goes away, right? Okay, as long as it's not us, we don't need to evacuate. That's what I was getting at. Okay, so the hand's pointing up. We're rising. We're gaining. Climbing. Increasing. These are all words I use to describe the situation of this function. Oops, I forgot what word I was spelling. On the far right side, we got the opposite stuff going on. So the dude in red, he's smiling too. He's smiling the biggest. You know why? He's on a roller coaster that's going down. He's about to go fast. Let's see, hand is pointing down. He has two hands pointing down. So he's like extra excited. Hands point down. It's like a ski slope. He's descending. He's losing, or he's falling. Maybe losing. When you don't get your jobs and you're tracking your bank accounts, I hope they look like this and not like this. You want to be gaining that money, right? So you want your function of your bank account to look like this. If it looks like this, you got to reanalyze your situation. Losing money. So we're falling, we're losing, we're decreasing, descending. All these words just going down, okay? So visually, from left to right is the trend we got to look for, okay? So characteristics of these. What's cool about today is we're gonna get into some actual real world situations. So you're gonna see a function that we can make use of, all right? Not a whole lot going on here, but everyone's got these words in, maybe some of your own. We're ready for page 37 if you are. Let's check the page. Cruise on over.